Something very strange is happening in the early universe, and scientists have no clue why. Their theories are failing to explain these strange mysteries. Scientists are finding thousands of strange objects in deep field images, and they have no idea what exactly they are looking at. Recently, astronomers have discovered many strange objects in the early universe, and they said that these are not galaxies because these objects are completely different compared to early galaxies. In addition, the Webb telescope looked deep into the universe beyond the dark ages for the first time, and what it found has astonished astronomers. There was a universe we just begun to discover, that distant galaxies have stars in them. The James Webb Space Telescope has already changed how we see the universe. But now, a Nobel Prize-winning scientist is making a shocking claim. According to them, the telescope may have discovered an entirely new universe, a revelation that could rewrite everything we know about space and time. For years, scientists have speculated about the existence of other universes, but this finding could be the breakthrough they've been searching for. Let's find out what it all means. Introducing the James Webb Telescope. The James Webb Space Telescope, often called JWST or simply Webb, has caused a surge of excitement among astronomers and space enthusiasts worldwide. People have long dreamed of looking deeper into the universe's early stages, but older telescopes hit natural limits due to their size and design. The Webb telescope changes that by being far more sensitive to infrared light, which is key for studying faint, distant objects. When light travels from these remote regions, it stretches with the expansion of space, shifting into longer wavelengths that are best observed in the infrared range. That is exactly what this telescope specializes in, and it does so with remarkable clarity. Its launch was a massive project that took decades to plan and build. Scientists and engineers across many countries contributed to its instruments and mirror segments, ensuring it could see faint details in the most distant reaches of the cosmos. Once in space, JWST began sending back data that quickly turned heads because it exceeded expectations, capturing features that, according to some models, should not have been visible yet. It saw galaxies that appeared to be too massive and too well-formed for the time period in which they existed. Even as experts double-check data and discuss possible errors, the initial surprise remains. The telescope is definitely seeing something unusual, and this has sparked debates about whether the standard cosmological framework might need adjustments. The cosmos is not just stars and galaxies. It is also a time machine of sorts. Observing objects that are billions of light years away means looking back billions of years in history. Yet with JWST, astronomers are peering into more than just any old snapshot. They are venturing into periods shortly after the Big Bang, when the first structures were forming from hot, dense matter. The standard picture, built on observations from instruments like the Hubble Space Telescope and large ground-based observatories, suggested a gradual buildup of stars and galaxies over many hundreds of millions of years. But JWST found evidence of bright, mature-looking galaxies that might have appeared when the universe was only a couple 100 million years old. Many are now asking if something unexpected happened back then that made large cosmic systems grow more quickly than we believed. The push to explain these findings is intense. Astronomers have formulated theories involving dark matter, dark energy, and cosmic inflation to describe how the universe began and evolved. For the most part, these ideas have stood up to countless tests, from measurements of the cosmic microwave background to galaxy surveys. Still, each time a new, more powerful instrument comes along, open questions can take fresh forms. The James Webb Space Telescope has reawakened some of these questions. Since its infrared vision allows it to see details that were invisible to earlier telescopes, new details can either confirm older theories or undermine them, setting the stage for bigger changes down the road. At this moment, many theorists and observers agree that JWST is pushing the boundaries of what we thought we knew. While it is unlikely to wipe out everything about our current cosmological model, it might highlight areas where we got the speed or timing of evolution wrong. That alone would be exciting, since it would mean revising timelines and processes in early structure. The telescope's reach has also made it possible to observe star-forming regions at levels of detail that were previously impossible, giving insight into how dust and gas collapsed into the earliest star clusters. As if that were not enough, It is also detecting signals that hint at the presence of possible supermassive black holes and other mysteries lurking at the dawn of time. The potential for a paradigm shift. The idea of a paradigm shift might sound dramatic, but astronomy does have a history of making big leaps. People once believed Earth was the center of everything, and it took centuries of observations and debates to overturn that assumption. Later, we realized our galaxy is just one among billions and that the universe is expanding. New telescopes and better measurements often drive these changes by bringing hidden details to light. The James Webb Space Telescope now steps into this tradition. Its design allows us to see cosmic epochs that were only theories before. If the data continues to hint at galaxies that appear to form too quickly or exist in greater numbers than expected, it may force us to think deeply about our standard models. One of the biggest areas that might face change involves how matter clumps together in the early universe. Scientists have spent years refining calculations for how dark matter halos help galaxies form. In standard thinking, gravity gradually pulls matter into organized structures, which then seed more complicated formations. This process is not instantaneous. It takes time for gas to cool and condense enough to create new stars. All these steps were assumed to occur in a predictable timeline. However, some of the galaxies observed by JWST suggest that star formation happened extremely fast, not in a typical slow burn that astronomers anticipated. If star formation is getting a second look, so is the quantity of normal matter that pools into these early galaxies. Typically, only a fraction of available gas turns into stars, but some of the new observations hint at near total use of that gas. That is tough to reconcile with standard star formation models, which assume that processes like supernova blasts, stellar winds, and other feedback mechanisms keep much of the gas from turning into stars all at once. If the telescope's data holds up, it might mean early galaxies had ways to transform gas into stars more efficiently than modern galaxies do. Some propose that these first stars were so massive and hot that they acted to explode in powerful supernova events, seeding their surroundings with heavier elements at an accelerated rate. But even that only goes so far in explaining how quickly we see big collections of stars forming so soon after the Big Bang. Another angle to consider is the mass of these newfound galaxies. The telescope's observations make some of them appear far too heavy for their place in the cosmic timeline. Calculations about how much mass could gather in a few 100 million years do not readily match the presence of so many stars. If such objects are confirmed by further data, the big question becomes, did dark matter or some unknown force assist in speeding up the gathering of matter? Or are we mixing up redshifts and maybe overestimating their distance and age? Scientists need to verify each data point to rule out simpler explanations before revising fundamental theories. But the number of these odd objects keeps growing with every new deep field image, suggesting it is not just a rare outlier, but possibly a widespread phenomenon. Throughout this debate, experts remain cautious. Paradigm shifts do not happen overnight, especially in a field as data-driven as astronomy. Yet the steady flow of puzzling evidence from JWST has sparked serious conversations about whether slight alterations to the lambda-CDM model are enough, or if new physics might be lurking. The phrase new physics can spread excitement or skepticism, depending on who you ask. But either way, the telescope's role as a catalyst is undeniable. At the very least, it has made astronomers revisit the steps that lead from primordial gas to galaxies teeming with stars, pushing them to look for flaws or oversights in their older process-based theories.